Well, I hope you're getting the drill by now. What I want you to do is pause the video, have a look at the question, draw the summary step. Okay, there we go. So the question's asking us what velocity. Now, get our head around this question here. If we were on the Earth, if that was the frame of reference we were on, and we're looking at the spacecraft, we're going to see their clock run slow. Now, it's going to take a minimum of 100 years. In fact, it'll be a little bit over 100 years because you can't travel at the speed of light. But if they did travel at the speed of light, to travel 100 light years, which is a measurement of length, not a measurement of time. Okay, 100 light years is a measurement of length. Okay, so for them to travel 100 light years at the speed of light takes them 100 years. So the best you could hope for is just a bit over 100 years. There's no way this patient's going to make it home in time. But when we look at their clock, we're going to see their clock run slow. We're going to see everything happening slow for that sick patient. So it is actually possible to get them home in less than a year from their point of view. So if we put ourselves here in the spacecraft though, what are we going to see? We're going to see length contract. It doesn't look like we've got 100 light years to travel because that length is going to get contracted. So how fast, because the faster we go, the more the length contracts, and therefore the quicker we're going to get there. And of course we're going faster, so that kind of compounds the problem. Or compounds the effect. So what velocity have we got to be at so that the elapsed time on the spaceship is 1 Earth year? So what's really important to remind ourselves here is we're going to do everything in the convenient units. We're going to measure length in light years, we're going to measure time in Earth years, and we're going to measure speed in terms of the speed of light, c, the speed of light. Okay, so actually this is a very simple question to set up. It's the algebra that becomes a little bit ugly later on. So velocity is really just very simply distance divided by time. So if we think about the spacecraft, it'll be whatever the contracted length they see is divided by whatever the time is, which of course is going to be 1 year in their frame of reference, in that frame of reference, okay? And that's simply L naught outside of square root of 1 minus v squared on c squared. And we're going to do our little trick here. Whoops, we're going to let c equals 1 because that's the units we're going to work in, the speed of light, and that simplifies our equation down to v is L naught outside of 1 minus v squared on tv. Now what I'd like you to do now is to pause the video here and have a go at the algebra. See if you can solve that for v, and then once you've done that, it's a pretty simple thing to plug the numbers in and get it. So pause it now. And I'm presuming if you're playing again here that I hope that you've had a go with the algebra, and either you think you've got there and you just want to check yourself, or you got completely lost and you've given up. And if you got completely lost, that's okay. We'll do it together and then we can learn how to do it from here. Okay, so we've got v tv on L naught is going to be equal to the square root of 1 minus v squared. Let's square both sides here. We're going to take the v squared across to the other side. Okay, now we need to get everything on a common denominator of L naught squared. Oops, sorry, that's a plus. It's a plus there. That equals 1. So we've got it on a common denominator. We're going to now take out our v squared term out as a factor here. So we've got let's just jump over to here. So we're now got a common factor, so that's going to give us v squared is simply going to be L naught squared on tv squared plus L naught squared. And so v is going to be equal to the square root There we go, we're done. We've got our equation in terms of v. We simply have to put in our values for everything and substitute. So that's going to be the square root of 100 squared on 1 squared plus 100 squared. Let's grab our faithful calculator out here. So what do we have? We want the square root of Okay, there's our velocity. We're going to have to travel pretty fast if we're going to get this sick patient back in a year.